move on. So, what's the difference between translating a weak entity to tables and a one-to-many relationship? Translating that to tables and a weak entity. What's the difference between the two? There's just one small difference. Yes?
The weak entity by itself doesn't have
So, thank you, Jenny. Maggie. So the only difference is that in a weak entity scenario, in order to get a key for that, you need to have the key of the province as part of the key. If it's not a weak entity and it's just a one-to-many relationship, you're going to still have that attribute inside your table, but it's not going to be part of your key. That's the only difference. One more question. So we talked about here, if this is a one-to-many relationship, it is that I can combine these two. What if it's a one-to-one relationship? If I have a one-to-one relationship, then what can I do? Yes?
You can combine all three tables?
You can combine all three tables. Now you don't get the problem that we had before, right? Because since now it's 1 and 1, we're not going to get Samuel L. Jackson's records 50 times because it's just going to happen once on either side. Okay, so any questions? Alright, then let's move on and talk a little about inheritance and generalization and how we can take inheritance and how we can model that using tables. Just to note that if there was part of the previous lecture that you missed, now is a good time to start listening because this is totally irrelevant to what we're doing so far. Okay? So if you feel like you're lost and you can't follow on, you can follow this. And everything else we've seen so far, there hasn't been really much judgment. Right? I haven't told you that there are multiple ways that you can do this, and you need to make a judgment on how you want to do this. With inheritance, we're going to talk about 3 different ways that you can do this, and there is a judgment that needs to be called. The question is, I have movie people as my superclass, and I have actors and also musicians. The question is, how can I model this using tables? One way would be that I can have different tables that go for each of these concepts. So I'm going to have one table for movie people, and it's going to have ID, name, birthday, agent name, and instruct. I'm going to have one which is for actors, and I have one which is for musicians. So it has the same attributes. I have 3 different ones, and depending on what it is, whether it's an actor, then I can add it here. If it's a musician, I can add it here. If it's a movie person, I can add it here.
Can a movie person be an actor and musician at the same time?
These are the things that you need to make a judgment about. So when I say you need to make a judgment, it's exactly these kind of things that you need to ask. That is it the case that a movie person can be an actor and a musician at the same time? Is it the case that all our movies are either actors or musicians? Or they could be directors as well, then we don't have a class for directors. So this one is not in the textbook as one of the methods. And there's a lot of redundancy because we have 3 different tables. A lot of nulls need to be taken care of because if you have an actor, that actor wouldn't have an instrument. If you have a musician, that wouldn't have an agent name. So not a good way to do this. So let's just put this one aside and think about the 3 other models which sometimes would make sense. table. That big table is going to have the attributes of my movie people and agent name and instrument. And I only have one table. One problem is that there's going to be lots of nulls because my musicians will not have agent names and my actors won't have instruments. But that's just one of the problems. Talk it over with your neighbors and see what other problems you can find. Right, does anyone have any answers? Yes?
If I wanted to look up actors only, then I would have to look at movie people and then look at all the ones with the roles.
So, the answer coming from that side is, if I want just to look at actors, then this is a big table that I need to go through and put away all the ones that their agents, they don't have an agent, right? That's a good answer. So if a lot of my queries are just on my actors, and I don't really care much about my musicians, then I'm querying a bigger table, and every time I need to look at whether they have an agent name or not. Plus, having an agent name is not mandatory. So I could have an actor who doesn't have an agent name, then it would be also hard for me to know whether this person is an agent or whether there's something else. Any other reasons? What if there's a relationship that only actors can participate in? Right? Let's assume that I have a relationship coming out of my actors, so only my actors can participate in that relationship. Once I put everything together, then I can make that restriction for only my actors to participate in that relationship.
Should we bother with agent name and instrument, for example? Because for me, it looks like ID is unique. So if a person is an actor, it will have a unique ID, right?
Right?
And we can distinguish that person from musicians and movie people.
So in this solution, I'm only keeping one table. Right? So there is no other table. If I want to keep that information somewhere, it's going to be in this table. So I can't get rid of that agent name.
Oh, okay. You cannot.
There's only one table. Okay, so this is a big restriction. The big restriction that if you want to have relationships that only works for your actors and musicians, doing this method is not going to work. Well, if I have everything in one table, then that relationship would be by movie people. And then I need to come up with some other restriction to not allow others except agents to participate. Question?
Just add like two more attributes, actors or musician. Question. Identify the whatever the occupation is for a particular.
So the suggestion was to add another field which tells you what that person is, whether it's an agent or whether they're an actor or musician. Yeah, so we can have a code. If it's 1, that means they're actor. If it's 2, it means they're musicians. And if it's 3, that means, I don't know, there's something else. So that gets rid of the problem of whether you'll be able to identify actors or musicians, but still it's hard to have that relationship if you just want to have a relationship just for actors.
If you wanted to add another category like director or something, that would, I guess, difficult. You'd have to go through new call.
That's a great answer. So Ian's saying now, let's say I want to add another category, let's say directors. Then I have to go and redesign this table and add in a bunch of new attributes, which I'm now going to get null for everyone that I had. So making changes to my superclass table is usually hard. When would this be a good table for? If most of my queries are about my movie people, and I only want to know whether they're actors or musicians, but I don't really have much more information or relationship going with those, then this might be a good way to do it. Other than that, probably not. Let's look at a different way of doing it. Let's delete agent name and instrument from here. Let's have movie people, so I'm going to keep their ID, name, and birthday. I'm going to have an actor table, where that is going to keep the ID, so I can go back and check the rest of their information, and agent name. I have another table, musician, which now is going to keep ID and instrument, and these are going to be the 3 tables that I have. And this is pretty much what we do in general programming languages when we have inheritance. You have a superclass, and the subclass is only going to be implementing whatever new they have. The rest they're just going to call the superclass. Right, so discuss this one with your neighbors again about the advantages and disadvantages. Alright, advantages and disadvantages. Anyone? Yes?
Maybe the actor is also a musician, so there's a redundancy.
If an actor is a musician, there's redundancy.
Yeah.
So if you have, your name?
Jerry.
Jerry? So if you have a lot of overlap between your different classes, there's going to be redundancy. Why is there going to be redundancy?
Because an actor can also be a musician.
So what I'm going to do is I'm going to keep their ID, name, and birthday inside my movie table, right? I'm going to keep their agent name inside the actors table, and I'm also going to keep their instrument in the musician table. So I don't agree that there's going to be a lot of redundancy because I'm not keeping much of the information repeatedly in different tables, But the problem is now if I want to query that person, I need to join their information from 3 different tables in order to be able to talk about that person. Is that right? Or do you see a redundancy still? What would be the redundancy? Their ID we're keeping multiple times in different tables. But the main problem is that now we need to combine different tables in order to get their attributes. So that's a disadvantage. What might be an advantage of this model?
The advantage that if person is none of actors or musicians, you still have that person.
So if I have people that are not in my subclasses, I can still keep those information there fine. This model is really good if most of your queries are going to be about the superclass. Because to answer anything about the superclass, I don't need to join tables together. We're going to see later that joining is inexpensive, it's costly. It takes a lot of time if you want to take 2 big tables and you want to combine them. It's easy to get information from 1 big table.
Why would you combine both actors and musicians? Because if a person is an actor and if a person is a musician, by default, it will have the same ID, right?
They do. So every movie person has an ID, no matter whether it's an actor or a musician. So you get an ID. And if you're both a musician and an actor, the same ID will be shared between both tables.
Yeah, so why would we combine them?
So-
together with keeping all 3 attributes, ID, age, and name, and instrument.
So the suggestion is have 1 superclass and then one subclass, where that subclass is going to keep information from all the different subclasses, right?
Yeah.
Doesn't really work well because you might have, this is obviously an example, but let's say you have 5 or 10 different attributes here and 5 or 10 different attributes here.
Yeah, just
Then
keep
combining those doesn't
numbers.
really make sense. Okay, so this one, if I was designing this table, if I was designing this database, and if the person who wanted this database told me that most of the queries that they have is going to be about movie people, and once in a while they might ask whether someone is an actor or not, then I would go with this model. The third method would be not to really have a class for movie people. This is something Johnny was saying in the previous lecture. Have this as an abstract class, don't really care about it. Have 1 table for actors, which is going to have ID, name, birthday, and agent. Have 1 table for musicians, which has ID, name, birthday, and instrument. And don't really have anything about movie people.
And how are you going to deal with directors?
That's one problem. So one problem is that if I wanted to go with this design, the first question I would ask is it the case that everyone in your subclass, alright? The first question I'll ask is that, is it the case that everyone in your superclass is a part of your subclasses? If they are, then we might be able to consider this. If you have people which are just movie people, then you can't put them anywhere once you do this. What's the other problem with this model? Or what is this good for and what is it bad for? It's good if most of my queries are going to be on my subclasses. If I want to ask queries about my actors, or if I want to ask many questions about my musicians, this is a perfect example. If I want to talk about movie people, then that means I need to combine these 2 tables together and then answer questions, and that's again going to be costly. And the third problem might be, what if you have people which belong to multiple subclasses? Where are you going to keep those people? So, unlike other parts of the ER translation that we've seen so far, there's no real right answer here. There are 3 different methods that we can use, and based on the problem and the sort of queries that you want to be able to answer, you can take one design over another. And this is where the judgment of the DBA will come into consideration. Any questions? Right, let's get into aggregation and see how we can take aggregation and we can translate that into tables. So let's say we have people visiting bars and they drink drinks at this date, and this is the name of the drink that they want to go with. So I'm going to have 3 tables for my entity, so 1 for person, 1 for drink, and 1 for bar. And then I'm going to have 1 relationship for visit. This is a many-to-many relationship. I need to keep track of the SID of the person and the bar name. And this is a many-to-many relationship again, so I need to keep track of the ID of the person, ID of the bar, and name of the drink. There's also an attribute here, so I'm going to keep track of that attribute as well. If any of these are now, instead of many-to-many relationship, if this is one-to-many, again, then we're going to change the design into what we were doing before when we had a one-to-many relationship. Any questions? Now, if it's the case that whenever you make a visit, you buy a drink, then we can get rid of this visit table and just keep the drinks table, and that will capture everything. Right? So if on all of the visits you have a drink, then we can get rid of that one. Don't worry about that too much. These are then optimizations that you can think about whenever you're designing your tables. Alright, so let's put all the information we got today into work. And let's take this ER model that you designed previous lecture. Now let's say you want to take this and now you want to come up with the right set of tables that would go with this ER model. Right, so I encourage you to work with a few people so then you're not lost on your own. And the TA and I will also come around and help you guys. Thank you. Just so you know.
voice requires a section here, right? And roles will have sections just like here.
No,
Words that require a section, right? Voice
Voice itself.
Oh, direct is the voice now. And the word will have a voice.
I think I don't think
Yeah. I'll go with
it's not a voice. You just have what's the point of the section? What's the point of the section?
The example we read past, the one
One table for all. Yeah. Here's what my course Oh, I didn't have first one. Wait, course. Now I need okay, you can do the relationship first, but that's what we So one for all three of them. I'll be in the middle of
Well, let's say fiction year is
In this case, because you only have one minute. Well, you are just make it its own style. Yeah. But you don't have to do that. Oh yeah, it's
So,
identify more people. Oh, really? Good. That might be a good one. You have to add the course number in the pattern. Otherwise, they couldn't do one thing.
Yeah, I was looking at
Instructor in the key section. The key section, of course.
Is anyone stuck? Or they not sure what we're doing?
Yeah. I think you should use that. I think I have taken like off section.
Right, can I get your attention, please?
Then you have attention and
Okay, so student, we have a bunch of information on student, and we know SID is the key. There are different ways that you can implement the visiting student part, based on what we were discussing before. But one way would to be have visit student, where you keep the SID, home institute of that person, and the starting date. And there's be a foreign key where that SID is a foreign referencing student table. For course, our courses have department, course number, title, and credit, and these two are defining the key for that table. Instructor, name of that instructor is the key, and they're also keeping their degree. Now, offering might have been a little tricky. So we're combining section and offering to have one table, and department, course number, section number, and year together are going to define the primary key for our section offering. And we need to make sure that the department and the course number, so we reference that from the course table just to make sure that course number and that department exists. Any questions so far?
Offering does not have information about a student, or should it? Enroll students.
So offering, let's say that currently we have an offering for CPSC 304 for the summer. That's the offering. There's a different table, enrollment, where it has a relationship with student, and there's where we're going to keep the information. Yeah?
do we not need the instructor name for the offering?
The question is, do we need the instructor name for the offering? That could be a choice design of how you do it. The way we have it right now is no, because you're going to have a teach relationship, where that teacher is going to say that instructor is going to be teaching this offering. Any other questions? Alright, so teach, an instructor will be teaching a section offering. Okay, so you need a bunch of stuff for the key. You need the information from the offering, so that's department, course number, section number, and year. And also the name of the instructor. Note that you can't just keep the section number and year plus instructor name as the key. Right? If you just have the section number, let's say it's 101, the year is 2010, and the name of the instructor, that doesn't really give you enough information to be the primary key of teachers. So you need all 5 attributes for the primary key. Foreign key, you need to make sure that that department and course number, section number, and year exists. So you need to make sure there's such an offering. There should be another foreign key for the instructor as well, to check the name of the instructor. The total participations, the thick lines that we have here, are the ones that we mentioned we cannot currently do, and we need assertions. Okay, so foreign keys, you need that from the offering table, and you need that from the instructor table. Total participation, we cannot show yet. Enrolled. Now we're going to keep information about students. So SID of a person, and information about the offering, department, course number, section number, and year. And also the mark. So mark is an attribute of enroll. Now we're going to keep here. We're going to have foreign key constraints to make sure the student exists, and also the offering exists. Any questions? Rahat?
Couldn't you possibly merge your instructor and teach together, since every instructor has to teach a section?
The question is, can we not combine information from instructor and teaches just because everybody has to teach, right? That would be a bad idea, because an instructor will be teaching multiple classes. So that would mean that you will be keeping that information multiple times. So if an instructor has taught 10 different courses throughout the last few years, you keep that 10 times. If it was a one-to-one relationship rather than a thick line, then what you were saying made sense. So if it was the case that only one instructor could teach an offering, then we could combine those together.
But then, wouldn't you need to store that information anyway in that table?
Which information?
Okay.
So currently, I'm only keeping the information for the instructor once. If I combine those, I need to keep it multiple times. Does that answer your question? No? Yeah?
Yeah.
Come and see me after the lecture. Prerequisite is the relationship between course and itself. So we're going to have course department, course number, prereq department, and prereq number as the information. Foreign key, course department, course number to make sure the course exists, and also prereq department and pre-number to make sure the prereq also exists. Any questions? Okay, so this kind of question seems like a great midterm or final question. So make sure you feel comfortable taking an ER diagram and converting it into a logical design. Okay, let's summarize. Relational models is all about tables. We've discussed how you can take conceptual models and model them using tables. We've talked about integrity constraints and how those can be specified and how you can put those inside your tables. We looked at powerful natural query languages, just briefly. We looked at SQL. We're going to do a lot more of that later. And we also looked at rules to translate ER models to relational models. Learning goals, compare and contrast logical and physical data independence. you need to know the components of a relational model: tables, rows, columns, keys, and associations. You need to be able to create tables, alter them, and delete them. Explain and differentiate different integrities that we talked about: one-to-many, many-to-many, weak entities, full participation, partial participation. Explain the purpose of referential integrities, why we have them, how we can enforce different referential integrities, and how to map ER diagrams to relational models. Any questions? All right, have a great long weekend.